Today we're going to use the power dissipated in a resistor to find the brighter light bulb in a circuit with two light bulbs. Let's derive two equations to find power dissipated in a resistor, or in our case, a light bulb, which is essentially a resistor. One must depend only on the current and the resistance, and the other one should only depend on the voltage and the resistance. Using Ohm's law as it pertains to power, we know that power is equal to the voltage times the current. Now let's find the equation that relates power to current and resistance. If you look at Ohm's law as it pertains to voltage, and I'll draw the chart here for that. We have V, I, and R. The one we'll use for our first derivation is going to be V is equal to current times resistance. And we'll plug that in up here for our V. Power is equal to current times resistance times current, or I squared times R. Now let's keep this equation in mind and move on to the next equation that relates power to voltage and resistance. For this one, we're going to look at the equation that uses voltage and resistance. So if we go back down to this voltage chart, we see that current is equal to voltage over resistance. Now we can plug this into our power equation. So we have power is equal to voltage times current, or we have voltage times voltage over resistance. Otherwise, we can write voltage squared over resistance. Now we have our two equations that will be useful in finding the power dissipated in a resistor. Power is equal to current squared times resistance, and power is equal to voltage squared over resistance. We have here a circuit with two light bulbs hooked up in series. One is 5 ohms and one is 10 ohms. Which one will shine the brightest? Now, because these are in series, these two bulbs will have the same current running through them. So we'll use the first equation here. This is because it has to do with the current. And we'll find the ratio of the power dissipated between the two bulbs. So let's fill in our values. We don't have current, so we're just going to have I squared, and then the resistance 10 ohms over I squared 5 ohms, and this is for power for the 10 ohm resistor light bulb, and this is for power for the 5 ohm light bulb. So because they have the same current, we can cancel out I squared for both, and we are left with 2 over 1. that's the ratio. The power dissipated is 2 to 1. The 10 ohm bulb is going to be twice as bright as the 5 ohm bulb. Now we see that the two bulbs are connected in a parallel configuration. So now which of the two will shine the brightest? Now because they're in parallel, they're going to have the same voltage. So we'll use our second derived equation, which has to do with voltage. Power is equal to V squared over R. So let's fill in our values. Now, because they have the same voltage, we can cancel these out. So we're left with 1 over 10 ohms over 1 over 5 ohms. And with this, we get 1 over 2. So now this time we see the 5 ohm bulb will shine brighter than the 10 ohm bulb. This is because the lower the resistance, the more current you're going to get, resulting in a brighter glow. So that's how we can use power dissipated to find the brightest bulb in a circuit. Thank you for watching.